So lesson 2-3 deals with direct variation. And this is probably going to be something that's a little new for most of you. I don't know exactly what you guys covered last year or the year before. But the main thing in this is terminology. It's really not super difficult if you understand equations of lines. You know, in equations of lines, we have something like y equals mx plus b. There's the slope-intercept form of the equation of the line. And you know what the different letters represent. The letter m represents the slope, and the letter b represents the y-intercept. I mean, that's something that you guys didn't know before 8th grade, whenever you learned it. Well, this is some different stuff about equations of lines, but in these equations of lines, we're not going to have a y-intercept, meaning that the y-intercept is going to be 0. So you're just dealing with y equals mx as the equation of a line, because b is going to be 0. It's not going to exist for these. And we'll look at that on the graph here in just a second, although the graph is not super important as far as understanding this. But anyway, in these special situations, whenever b is 0, and we have just y equals mx, then we rewrite, we don't use m, we use y equals kx, because this shows us a very special relationship. It's a relationship where y is said to vary directly with x. And guys, there's the terminology you got to learn in this lesson. If y varies directly with x, you know you're going to have an equation that looks like this, and they're going to ask you various questions about that equation. Another one is, a direct variation. It's called a direct variation. So you're going to be determining, does a direct variation exist? And then also you're going to have to be able to find the constant of variation, k. And that's kind of what I've got down here kind of summarized for you. As you look, we're going to use our new knowledge, everything we're learning here in 2-3, to look at some data, most of the time represented in the old T-chart form, or it could be a group of ordered pairs, but most of the time in this it'll be a T-chart, and look at data and determine if it represents a direct variation or not. Or then we're going to look at an equation and determine if a direct variation exists. In other words, does it represent a direct variation or not? And then we're going to use what we learned to find the constant of variation, k. And then we're going to combine all of that together to solve word problems that do contain that terminology. So let's look at it. First off, the equation. This is very simple. If an equation is given to you and it's not solved for y, you solve that equation for y, and then you see if you have a y-intercept or not. For instance, if I have an equation that looks like this, y equals x over 2. Now, guys, you've got to understand x is in the top, right? That can be, that equation there is the same as y equals 1/2 x. And so the answer would, does a direct variation exist? Is this an equation of a direct variation? The answer is going to be yes. And then what's the constant? Well, the constant is just that k, remember, where the slope is. So it's that the constant of variation in this equation is 1/2. All right. And again, if we were to graph that, we would see that it does indeed go through the origin. It's 0. And then the slope is over 1 up 2. And the graph of that would be like so. Not a huge deal. Okay, it's very important that we understand the terminology. But what kind of problems you're going to do? I think you'll find they're going to be pretty easy. If you look at example 1 in your book, it says identifying direct variation from a table. It says for each function, determine whether y varies directly with x. If so, find the constant of variation and write the equation. How are we going to do that? Well, the first function on the a part, again, it's in a T-chart for us. So I'm going to draw a little T-chart where we have x and y, and we have 2 and 8, and we have 3 and 12, and we have 5 and 20. All right, so what we're going to do, if y varies directly as x, if I were to go back up to this, and I would want to, let's say I'm wanting to find or solve for k on this equation. Well, I would divide both sides of this equation by x, right? And so I would divide by x, I would get k on this side equals y over x on this side. Whoops, out of the screen. You see that? So if I were to divide by by x, and divide by x to solve for k, then that's what I would end up with. Well, that's what I'm going to check. I'm going to put y over x and see what I get each time. Go down to our example here. Y is 8, x is 2. If I put y over x, I get 8 over 2, and that gives me 4. Do the same thing for the next pair. Y is 12, x is 3. I put 12 over 3. That gives me 4. Now let's go up here and label this. What am I doing? I'm doing y over x. But I need to remember that that is k. All right? So here, y is 20, x is 5. So 20 over 5, that gives me 4. So I get the same number each time. That tells me, yes, this is a direct variation. And the constant of variation, k, is 4. And the equation is simply y equals 4x. Okay? Now, let's look at one, example B here. Okay? It says, we got our x and y t-chart. Okay? And on this one, x is 1, 2, and 5. And y is 4, 7, 16. 4, 7, 16. So I'm going to do y over x. Remember, this is k. I'm not going to write the k up there this time. 4 over 1. Y is 4. X is 1. 4 over 1 is 4. 7 over 2. Well, that's 3.5, or just 7 over 2. That's not 4. And that's enough to tell me that the answer is no. A direct variation does not exist. Of course, you can just answer no, but I'm trying to make it as plain as I can for you. You see why it's no? Because we got a different answer for y over x on this. And of course, we're going to get a different one on this one as well if we were to carry it on. But just once we get a different answer, we know, hey, that's it. I quit. It's no. All right? Now, let's look at another one. One more t-chart. This is going to be check understanding. And this is going to be A. X, let me get my, and Y. And we got -6, 3, and 12. -6, 3, 12. And then we got -2, 1, 4. -2, 1, 4. Okay, so we're going to put y over x. Now remember, this is where reducing fractions is important, because I get a -2 over a -6. Well, that's positive 2 over 6, because two negatives make a positive. And 2 over 6 reduces to 1 over 3. Yeah, k is not always going to be just a nice, neat whole number. It can be rational numbers or fractions. All right. So this one, y over x, 1 over 3. Well, that's 1 over 3. Okay. This one, y over x, 4 over 12. That reduces to 1 over 3. They're all positive 1 over 3. So the answer is yes. The constant of variation is 1/3, and our equation would be y equals 1/3 x. Okay? So that's how you look at t-charts of data and answer the question, is it a direct variation or is it not a direct variation? Okay, and then how to find the constant of variation, and then how to go ahead and write the equation. All right, let's look at, though, looking at equations. Change thoughts right here. What if I have an equation here? Like example 2. I've got 3y equals 2x. Okay? So the same question, does y vary directly with x, or is this a direct variation equation? Well, the first thing I can do is solve for y. So it means I'm going to divide by 3, and I get y equals 2/3 x. Now remember how I tell if this is an equation, if it's a direct variation or not? Do I have a y-intercept out here if I'm thinking in terms of y equals mx plus b? I don't. So the answer is yes. And then the constant of variation would be 2/3. Simple enough. Let's do another one. What if I have this equation? Y equals 2x plus 3. Again, I'm looking at example 2 on page 73. Once again, it's already solved for y, so I don't have to solve it like I did this one. But when I look at it, it's y equals 2x plus 3. I have this y-intercept hanging out here. Anytime I have a y-intercept, it doesn't go through the origin. Therefore, the answer is no. This is not a direct variation equation. Anytime we have that. Let's look at something else. Here's you one. I'm looking at the check understandings there on page 73 underneath example 2. And I'm going to look at C, problem C. Check understanding, example 2. This is C. All right, C says we've got 5/6 times x equals 1/3 times y. Now our job is to solve for y to determine, is it a direct variation or not? So to solve for y, I got 1/3. We multiply by the reciprocal, 3/1. Same thing to this side. Boy, if I learned fractions in 5th grade, this is really easy. Y equals 3 cancels into 6, and I get 5/2 x. And then I can just flop it around, put y on this side and 5/2 x on this side. So I've solved. And so my answer is yes, because I don't have after I've solved for y, I don't have a y-intercept out here. And so my answer is going to be yes. And the constant of variation, k, is 5/2. Again, it's all about the terminology. All right, I'm going to stop, and then we'll come back with another video to show how to do some word problems.